First and foremost, I just wanted to take a moment and thank everyone that watched the first video as I was introducing this new little TRF set from the mid-1930s. It appears to be a Majestic International based on all the information I've been able to research. And again, I appreciate everyone that chimed in, that provided insight on the origin of the radio. Much appreciated. Anyway, I took time, as I mentioned. I was going to create a kind of a hand drawing of what I could see underneath, and I've gone back and triple checked myself, so this is kind of the way everything is routed out from underneath and laid out. You can see some of the components I have identified based on the color codes, and others I've yet to been able to do so. Due to wax or other, like on some of the capacitors themselves. So more to come on that, but I'll turn this into a schematic at some point in time, most likely. But this will be helpful. You'll notice I'm not showing the heater circuit here on the tube layout, and I've got a separate diagram just for the heaters themselves. So here you can see those Oddball rectifier tubes. They're actually in parallel with each other, so we'll spend more time and talk about those in a future video, as well as the the heater string itself. Again, it's in series, so there was a curtain burner or resistive line cord on the radio, which I've removed. And you can see it tied here to point number 2 on the first 6Z5 rectifier tube. Anyway, I'm going to start taking this thing apart so I can get the chassis down to bare bones on the front, start cleaning that up. You guys saw me spend a lot of time on the Peter Pan radio. I'm going to forego a lot of those steps and not show that level of detail in this video. You can reference back to that if you're interested, but I'm going to just do a little rust cleanup and again just get the chassis in good shape. After I take time here to get the old volume control on-off switch off, as well as the tuning condenser, the speaker with the integrated field coil down here, and the output transformer. So that's kind of what's on the agenda here for the next hour or so in the shop. I'm going to go ahead and get that done, then I'll come back and provide an update. And we'll start doing some individual tests here on the condition here of the transformer, the speaker, the volume control, and the tuning condenser, just to make sure they're in good health. Closer look at the speaker cone. Looks to be in pretty good shape. Maybe a tear right there. You can see how tough things were back in the day. They just used any type of hardware they could. Again, these were the 2 fasteners that held the speaker in. And of course the same nut, but just any screw that looks like it would work or serve the purpose. Interesting how they had this thing mounted in here. Again, it was just wedged underneath the chassis mount here, back over to that one longer screw that came through to, that held the speaker itself in. And you can see where it was kind of wedged in there. I reckon back in the day they just did whatever. Again, it wasn't attached in any way, just kind of lodged in there. But I appreciate, again, the feedback I got. I think somebody was able to pick that up. Again, I was trying to work at an angle and look through a camera when I was filming the part 1, but it does appear to be, I reckon, what, Dumont Electric Company in New York, made in the USA, and there's the licensed under a patent number, so it should be a dry electrolytic condenser. So maybe I'll pop this open and see how easy it is just to gut everything, and see if I can actually clean this up a little bit more, straighten out some of the damage, and just restuff it with the modern day caps. And here's the capacitor bank itself. that's showing up. So we've got a red 16 microfarad at 200 volts. Looks like a yellow, and it's been marked through. It looks like maybe an 18 microfarad at 200, and then the green at 5 microfarad at 35 volts. And I think there were 2 negative leads here that are just soldered back down to the chassis ground. So I need to redress this anyway, and let me just double check my documentation to make sure I've got all my tie-in points here correct for the positive side of the electrolytic. They're noted correct on my documentation, and then I'm going to just clip these off, and then we'll pry this thing open, see what it looks like inside. You can see all these old leads here broke up anyway, but all my documentation does match. So we can cut these off here. Just shows you how simple these TRF receivers were back in the day, but still a great player under the right conditions. That choke is pop riveted in, so I'll probably just try to get the rust off from around that area, clean it up, and we'll check the inductance as well as the DC resistance just for reference. But there's almost a bare bones chassis now, and again, there's not much underneath. I think I can actually clean everything up the way everything is. And these tabs are just falling off. So the idea of being able to maybe salvage this, I'm not sure. Time will tell. But there's a close-up look for those that may need this for reference as well. Okay, again, I'm not going to bore you guys with this, but I'm going to just take some wipes here and disinfect this. And if I can uncover more written information on the chassis itself as I'm going through this process, I'll provide updates. But first thing I want to do is just do an initial cleaning itself and see if it's going to even be worthy of using naval jelly or other rust removal on the chassis itself. Okay, that's what a good bath does. So it cleaned up pretty good. Little rust removal there. I think I will take the naval jelly and go over the top of the chassis, then try to get under excuse me, try to get underneath as well in a few spots right here on these rivets that hold the tube sockets in, and over here in this area as well. But other than that, that's about it. And of course the choke itself. And if I can't clean this up on the frame as well as I'd like, I'll end up taking it out probably. Okay, I went on and took time to clean the speaker up too. Funny story, not really funny though, but my American reproducer sticker that was here on the back, when I was cleaning the chassis off with my shop vac with my miniature hose, it decided to take off. So it's in a million pieces. The great thing is I've got some still photos. I think I can reproduce it and get one back on there. If not, you know, it is what it is. But I hate that. I didn't realize it was loose, and next thing I know it was gone. So you guys gotta laugh about those things. Let's check the primary impedance here of the output transformer located here just for documentation. And kind of what you'd expect to see, just around 513 ohms there. Alright, let's check the field coil. Hopefully it's good. It's weird too, this field coil. Let me show you guys this. It's weird too, this field coil. It's It's actually, most of them are so tight inside the yoke they don't move. This one actually spins around the center pole piece, if you guys can see that. And we've got DC resistance, so that's good. Just under 2500 ohms, as you can see, 2.49K. So let me document this information here on my notes just for future reference, and let me get my power supply hooked up. I think I'll go ahead and energize the field coil here, and I'll take my audio generator and generate a tone here. And I'm not sure what the current flow was through this. I'll just be cautious and stay maybe somewhere around 20 to 30 milliamps of current, and see if we can create enough electromagnetic force here that we can get some decent audio out of the speaker, just to confirm the secondary of the output transformer is working, as well as the voice coil and all the mechanics behind the speaker itself. Okay guys, this is my setup here. Again, the speaker, and then we've got the field coil here, and I'm going to energize the field coil with my high voltage DC power supply that's variable. And you can see I've got leads clipped on here. That actually goes back to my signal generator. And I've got my meter hooked up here in series with the field coil, so we can look at the current in milliamps. So let me flip on the signal generator here. It's turned on. And let me flip on my power supply itself. And what I'm going to do is just bring the audio signal generator up and see if we can hear a tone around 700 or 800 hertz. And I apologize, I've got a shop air conditioning running as well. So that's with my RF attenuation, actually the lowest point, so I'm generating as much signal into the transformer here on the primary side as I can at this point in time. So now keep an eye on the meter here. Let me go create some voltage here and current actually, and see if we can increase the amplitude of the signal here. Okay, I'll hold it right there for now, around 30 milliamps, and I'm going to back the attenuation down, or actually add some attenuation just for a minute. But you can tell here that the voice coil is working, the spider's working, and of course the field coil is good, and the output transformer's working as well. Let me vary the frequency here. Let me try increasing the current just a little more. Okay, I'm going to just keep it there in a safe zone for now. Again, just a quick test here of the speaker itself, the output transformer, and field coil. Here's the potentiometer or volume control for this set. Again, it resides in the RF section, so it really just attenuates the RF and controls the bias. And you can see it's rated at 25 ohm, and it represents 25,000 ohms. This is most likely, I don't think it's wire wound because it's too small, so it's probably a carbon track inside. This was what was bad in my Peter Pan radio, and again someone had substituted a 10,000 ohm resistor. So again, I like to use my analog meter. You can see I've got some jumpers on it here. I've already got it set to the times 1K, which would be times 1000. And let's just zero this out with my leads on. And again, I'm looking at it from an angle, so it may be different than what you guys see on camera. But that's close enough. And what I'm going to do again is just go across the far connections left to right. And that should give us the total DC resistance of the potentiometer. So that's what you're seeing there. So just maybe a little north of 22,000 ohms or so. Alright, now what we can do now is just move one lead back to the center location, or the wiper location. And I've got the pot turned off right now, the volume control. So as I turn it up and turn it on, and I'm going to just go extremely slow, we should show the resistance itself change. A little bit of a dead spot right in that area. It's not uncommon. These old tracks inside here just wear out over a period of time, and unless it's extremely bad, I won't look for a replacement. You see it tracking down here. And some of these already have on one side of the potentiometer, there's already 300 maybe to 600 ohms of resistance already built in, with this turned all the way down, and that's probably what we're seeing here. And that's the way a lot of them were actually made. So that's probably correct, even though we're not bottoming out to 0. Let me just go back the other direction again and see how it tracks. A little sensitive in that area, but overall not bad. Okay, now I'll switch the lead around again. We'll still stay on that center location. Let me go back over here and attach, and we should come down close to 0. And you can see we're there maybe around 100 ohms or so. Now I'll rotate the control clockwise. Again, a little bit of a touchy spot right in there, but it seems to be tracking pretty well. And there we have it at full clockwise position. I may try to spray just a little bit of cleaner down in this area, but I'm not going to try to take this apart and do anything with it. By the way, I'm going to go ahead and throw this in the Ultrasonic Cleaner, the variable tuning condenser here, and let it soak for a bit. And I'm going to take these mica pieces out here just like I did on the Peter Pan radio. Make sure I don't damage those. Oh, I have not checked the DC resistance nor the inductance of the choke, so before I conclude this video, let's hook up the meter here and see if we can get a reading here on this choke, just to make sure it's good. Okay, the choke itself, one side of it ties in over here to the second 6Z5 rectifier, and the other side ties in to what would be the 43 tube. So let's just look at DC resistance first, and I'll document that. So I'm right at 300 ohms here. Let me grab the LCR meter and let's check and see what the inductance shows. Okay, I'll tell you what I'm going to do. I'm going to go ahead and lift one side here of the choke that attaches itself here back to the 43 tube. Alright, now to get a good connection here, hopefully it's showing up where you guys can see it on camera. So for the inductor itself, we're showing 3.34 henries and 302 ohms. So not much of a change there. I'll go ahead and notate the inductance there in henries, the 3.347, just for reference. Again, this is a small choke. Kind of reminds me, form factor wise, about the same size of the Field Coil 611 that I just rewound. Kind of makes sense too. The frame itself may be almost a carbon copy. 302 ohms, so I've got less resistance, and again that reflects on the inductance itself. Alright folks, thanks again for watching. More to come soon.